This is Unit 7-1, and this unit is entitled Antiderivatives. So what exactly do we mean by antiderivatives? What does this term antiderivative mean? We sort of have learned a lot about derivatives, but what do we mean by an antiderivative? So if we start off with the basic definition of a derivative in terms of the power rule, we know that the derivative of x to the n to the dx is equal to nx to the n minus 1. Or put simply, we take the exponent and stick that out in front. That's the first thing we do. So whatever the exponent is of x, that becomes the coefficient. Then we decrease the exponent by 1, so that becomes n minus 1. So now we've got our nx to the n minus 1. So now let's look at an antiderivative, okay? An antiderivative, initially we take and we use this elongated s symbol, okay? So that's actually the integral, but for purposes of this lesson, we're going to call it the antiderivative. Antiderivative of x to the n dx. Okay, the first thing we do here is not to take the exponent and stick it out in front. The first step we do here is to increase the exponent by 1. So step 1, increase the exponent by 1. Step 2, divide by that new exponent. So as you can see, anti sort of means opposite. Well, basically the steps are opposite. We first deal with the exponent, then we take the new exponent and we divide by that. And then our last step is simply to add a constant, okay? Because we could have a constant at the end here. So as I said, step 1 is to increase the exponent by 1. Step 2, divide by that new exponent. And then step 3, add a constant c. So let's look at some examples here. So let's say we want to find the antiderivative of the following functions. So let's look at the first one. We've got f of x is equal to x cubed, all right? The antiderivative of x cubed dx, we're going to increase the exponent by 1, so 3 becomes a 4, and we're going to add 4 to the denominator, okay? That's step 1 and step 2. And lastly, we'll add c, the constant. So the antiderivative of x to the third dx is equal to x to the fourth over 4 plus c. Now, let's look at the other example here. F of x is equal to 5x to the fourth. All right? So we'll increase the exponent by 1. So now it becomes 5. All right? Divide by 5, but we've already got a 5 coefficient. So those simply cancel. And then the last step is to add c. Okay? The constant. So the antiderivative of 5x to the fourth is simply x to the fifth plus c. So let's look at some more complicated examples. Let's say we want to find the antiderivative of the following functions. The first of them is f of x is equal to 3 over x squared. The second is f of x is equal to the square root of x. First thing we're going to do is rewrite them, okay? And so instead of being 3 over x squared, we're going to write that as 3x to the minus 2 power. And instead of being the square root of x, we're going to rewrite that as x to the 1/2 power. All right, so let's look at the first one here, the antiderivative of 3x to the minus 2. We're going to add 1 to the exponent. So minus 2 plus 1 is going to be minus 1. We're going to divide by minus 1. So that means that instead of being 3, it's going to be now minus 3. And we're going to add a constant c to it. All right? Or we could rewrite it simply as minus 3 over x plus c. All right? The other one, x to the 1/2, we're going to add 1 to the exponent 1/2, so that becomes 3/2. We're going to divide by that new exponent 3/2, which is the same thing as multiplying by the reciprocal, or in other words, 2/3, and we're going to add c to it. So, and we could rewrite that as simply 2 times the square root of x cubed over 3 plus c. So what if we have an expression that has multiple terms, okay? In this case, we got f of x is equal to x to the 4th plus 5x squared minus 6x plus 1. How do we do the antiderivative of that? Well, if we take each term one at a time, x to the 4th, remember we're going to add 1 to the exponent, so it becomes x to the 5th, and we're going to divide by that new exponent, which is 5. Then the next term, 5x squared, we're going to add 1 to the exponent to make that 3, and then we're going to divide by 3. Then we got minus 6x, so we're going to add 1 to the exponent. The exponent here is actually 1, so if we add 1, that becomes 2, and then divide by that 2, so we got 6x squared over 2. Then the last term is 1. Well, if you think about that, that's actually 1 times x to the 0. So if you add 1 to 0, it becomes 1. Divide by 1, and that plus 1, when we do the antiderivative, simply becomes x. And then we cannot forget this, because you're going to forget it occasionally. We have to add the constant term c. All right, so what if we have a situation like this? Let's say we want to find the function that satisfies these given conditions. We're told what the first derivative is, and we're asked to find the function, given that the function evaluated at x equals 1 is equal to minus 4. Well, let's see how we're going to handle that. Well, the first thing I'm going to do is take the antiderivative of 8x squared plus 5, all right? Because we know that's the derivative. So let's take the antiderivative to get the function. So we add 1 to the exponent, and that is a mistake right there. That's instead of being 4, that should be 3. And we should divide, this should have been 3 up here. That should have been 3. So if it was actually 8x to the 3rd plus 5. So we add 1 to that exponent, so now it becomes 4. Divide by 4, plus the 5, add 1 to the exponent, becomes x to the 1, and then we add c. So just understand that the f prime of x is incorrectly written there. It should have been 8x to the 3rd plus 5. Okay, so now I've got to find out what c is equal to. I have the function f of x, but I don't know what c is equal to. Well, if you look in the given information, we were told that when x is equal to 1 on the function is equal to minus 4. So if I plug in 1 for x in f of x, I'll have 8, 1 to the 4th over 4 plus 5 times 1 plus c. We know that's equal to minus 4. So if I solve for c, I come out with c is equal to minus 11. So therefore, my function, which is what we were asked to find, f of x is equal to 2x to the 4th plus 5x minus 11. Okay? So here we were given what the derivative was. We were given a specific value of the function at a specific value, and we were able to then figure out, well, what is the function given that information. Okay, here's another example, more like a word problem. A particle moves along the y-axis with an acceleration of a to the t is equal to 2, where t is time in seconds. Okay, so we're given the fact that we have constant acceleration. The particle's velocity at t equals 2 is 5 centimeters per second. the position of the function at t equals 2 is 10 centimeters. What is the position of the particle at t equals 6? Well, the first thing we know is that the a of t is simply equal to 2. It's constant acceleration. This is what we were told up here in the words of the problem. So we know that a of t is equal to 2. We also know that the integral or antiderivative of acceleration is equal to the velocity. So if I take the integral of 2 dt, I should come out with the velocity function. And sure enough, I come out with v of t is equal to 2t plus c. Since we have a constant 2, if I take the integral, that's actually 2x to the 0. Add 1 to the exponent, divide by 1, it becomes 2t plus c. All right, we were told that the velocity at t equals 2 is 5 centimeters per second. So if I plug in t equals 2 on my velocity function, I know that that's going to equal 5. So that means 5 is equal to 2 times 2 plus c, or in other words, c therefore must equal 1. So if c is equal to 1, my velocity function is simply 2t plus 1. Now, I also know that the integral of velocity is equal to position. So if I take the integral of the velocity function, I should come out with the position function. So if I take the integral of 2t plus 1, add 1 to the exponent, it's going to become t squared, divide by 2, but I've already got a 2 out front, so that simply becomes t squared. 1, integral of 1 becomes t, and then I add c. So therefore, my position function is equal to t squared plus t plus c. So now we need to find out what c is equal to. Well, if you look back up here in the text, we know that the position of the function at t equals 2 is 10. All right? So therefore, I have my position function here, x of t is equal to t squared plus t plus c. So x of t is equal to 10. Then plug in 2 for t, and that enables me to solve for c, and that means c is equal to 4. So therefore, my complete position function, x of t, is t squared plus t plus 4. So I have one last thing, and that is to find the answer to what they're looking for. And what they're looking for is, what is the position of the particle at t equals 6? So I want to know the position at t equals 6. Well, we know what the position function is. So therefore, if I plug in t equals 6, I come out with the position function is 46, and the units are centimeters. So these are all the different ways you can use antiderivative, or as we're going to call from now on, the integral.